So again, welcome to College Algebra. In these lectures, we're going to learn how to graph equations, especially equations of a circle, and also how to write equations of circles. So this is our Unit 2, lecture number 5. Again, our main objective is to find the x and y intercept of a graph, and also how to use the symmetry to help graph equations. Then from there, we're going to learn about circles. First, how to identify the center and the radius of a circle. Then how to write the equation of a circle and how to graph the circles. So our main objective in this lecture is focus on circles. So first, we're going to learn how to find x and y intercept of a graph. As we said earlier, x-intercept means when y equal to 0, and y-intercept means when x equal to 0. So this graph don't have to be a linear. It can be either linear or non-linear. Here we can see that our first intercept here is when x equal to 0, the value of y. So that will be again y-intercept. We also have here b and a. You can see that we have a value of a when y is 0. So here we have two x-intercepts, because when y equal to 0, we get a value of b, and when y equal to 0 on the left side, we get a value of a. So x-intercept means when y equal to 0, what's the value of x? Then y-intercept means when s is 0, what's the value of y? So here, when s is 0, the value of y is c. So again, the definition is given here. In the figure A, we have x-intercept of a graph. When y is 0, we have a. When y is 0 again, we have b. So we have two x-intercepts. So the points where the graph intersects the x-axis. Then in graph B, we have y-intercept. Y-intercept means what point we have when the graph intersects the y-axis. So this is the y-axis and the graph intersects it. And when graph intersects on y-axis, the x is 0. The value of y is c. The same thing apply here. When the graph intersects x-axis, then we have x value, which is a, y is 0. Another x value, which is b, when y is 0. So when the graph intersects x-axis, it means y is automatically 0. The same thing applies when the graph intersects y-axis, it means x is automatically 0. So this graph is called parabola. Again, a parabola that is open upward. When a parabola is open upward, we may have the x. Again, first of all, to get the shape of a parabola graph, the exponent of the x in this case have to be 2. Only if it's 2. When it's 1, we get a linear equation. So if I have a equation y equal to x minus 4, I'll get a graph of linear. When it's 2, it's parabola. When it's 3, 4, it can be any form. The peak will change also. So when the x coefficient is positive, again, we have the parabola open upward, so we can get the minimal value. The minimal value is where the blue dot is when s is 0, y is -4. Now, if s should be negative, then we have the parabola open downward, and we can find the maximum value at the top. We will come to this in details when we start doing quadratic equation, how to graph, because again, quadratic equation graph is parabola. We'll come more detail on that. But for now, we should know that this graph is called parabola. Its lowest point is 0 and -4, and it's open upward because the equation, the x is positive, y equal to x squared minus 4. So use the symmetry to help graph equation. So symmetry will be a line. In this case, we can see there are several ways to which a graph can have symmetry. We have a vertical line here. The first point is s and y. The second point, s and negative y. And we have two graphs. They don't meet. And the same thing we have here also, negative s and y, s and y. And that will be our symmetry. So here they say if a point x and negative y, which is our blue section, the down point, lines on the graph whenever the point sy does, then we say the graph is symmetric about the x-axis. We can say that a symmetry is like a mirror image. So when we look at the x-axis, we see the graph of red, the top graph and the down graph, they are the same. It's a mirror image. So we say they are symmetric. A symmetric means when we come to a center of something, the left side and the right side are the same. It's like a mirror image of each. So again, we said that if a point x, which is the down and negative y, lies on the graph whenever the point xy does, the graph is symmetric about the x-axis. This implies that a graph is symmetric about the x-axis if we get the same x coordinate when we evaluate this equation at y or at negative y. And normally I will use the term the mirror image of the two. Now, secondly, we said that if a point negative x and y again on the left side here on the graph, whenever the point xy on the right side does, again, we have symmetric. This time, the y line or the y-axis is between them. So we say symmetric about the y-axis. This implies that a graph is symmetric about the y-axis if we get the same y coordinate when we evaluate its equation at x or at negative x. Again, I'll use the term the mirror image of the blue equation. To the left of y is the same to the right of y. So they are symmetric about the y-axis. Now, thirdly, we said that if a point negative x and negative y lies on the graph whenever the point x and y, you can see the 2 points here, they are connecting, does, here we say the graph is symmetric about the origin. This is not in x-axis. We can see x-axis is horizontal, y-axis is vertical. Those are the two previous. This time we have a plane. And also we can see the vertical, the line is crossing the point of origin. This is where x and y equal to 0. So that's why we say symmetry about the origin. The origin is where we have x and y equal to 0, where my arrow is. So the symmetry, the blue and the red graph are symmetry on the origin point. Now we can also do what we call the symmetry test. So we can test for whether x, y-axis, and origin. So now we say to test for x-axis symmetry, we can replace y with negative y. Replace y with negative y. If the resulting equation is equivalent to the original one, then we say the graph is symmetry about the x-axis. Again, y can be, for example, if y is 10, we are going to replace it with negative 10. Now, if the resulting equation is equivalent to the original one, then we say the graph is symmetry about the x-axis. Same thing, we can test for y-axis, which is opposite. Now, this time, to test for y-axis, we will replace x with negative x. If the resulting equation is equivalent to the original one, then we say the graph is symmetry about the y-axis. When we replace y with negative y, and the resulting equation is equivalent to the original, we said there's a symmetry about the x-axis. The graph is symmetry about x. But if we replace x with negative x, and the result is same as the original one, then we say the graph is symmetry about the y-axis. Now, to test for the origin symmetry, we say that to test the symmetry about the origin, we replace s again with negative x, and we replace y with negative y. Now, if the resulting equation is equivalent to the original one, then the graph is symmetric about the origin. So now let's see an example. Strategy for graphing equation. To graph various equations, we'll use the following 3 steps. Find the x and y intercept, test for the symmetries, and graph the equation by plotting points and making use of symmetry and joining the points with smooth curve. Again, we learned how to graph a linear equation. We said to graph a linear equation, all we need is 2 points. So I can look for only x and y intercept. Then when I get the 2 points, I'll draw a straight line across them. That's if you are, again, graphing a linear equation. But this steps is for non-linear. So even when I get my y-intercept, I don't know how the shape will be. So with the graphing a straight line is very straightforward. Find the x and y intercept, then draw a straight line across those 2 points. But this is non-linear. So even when I find the y and x intercept, non-linear, the shape can be any shape. So we can test for symmetries. Those are the 3 the steps we just saw, how to test for x, y, and origin. Then after we test for the symmetries, we're going to get some points. Then we can graph the equation by plotting the points, making use of symmetry, and joining the points with a smooth curve. So let's see how this works. Here they say we should graph y equal to absolute value x. Now to graph for this equation, the first thing we will do is to find the x and y intercept. Then we test for the symmetrics. Then we plot the points. Then we join the points with a smooth curve. So first, let's find the y and x intercept. So here we have y equal to absolute value x. When y is 0, x absolute value s equal to 0. Which means s equal to 0. So the x-intercept is 0 and 0. Same thing applies to y equal to absolute x. So if s equal to 0, to find the y-intercept, the absolute value of 0 is 0. So we get 0, 0. So here we have intercept is 0, 0, s-intercept, and y-intercept also is 0, 0. The equation is y equal to absolute value x. So when y is 0, absolute value x equal to 0, so s equal to 0. And when s is 0, absolute value 0 is 0, so y equal to 0. So we get 2 points, but they are all in the origin. So step 2 now, we need to test for the symmetries. To test for the x-axis symmetry, we replace y with negative y. So now y equal to absolute value x. We are going to make it negative y equal to absolute value x, because we are testing for x-axis symmetry. So we replace y with negative y. Now, since equation 1 and 2 are different, we say that the graph is not symmetry about the x-axis, because y equal to absolute value x and negative y equal to absolute value x is to give us 2 different answers. So there is no symmetry about the x-axis. So we check for the symmetry with the y-axis. So if I'm looking to test for y-axis symmetry, then I'm going to replace s with negative s. So y equal to x and y equal to negative x, absolute will give me positive x. Negative absolute value will give me. So this means we have a symmetry here. but this time the symmetry is for y-axis. We replace s with negative x, we get the same answer. So since equation 1 and 3 are the same, the graph symmetry about the y-axis. So now we are going to test the third one. We test for the y with axis, x-axis. Now we are testing for the origin. Origin, we said we have to make everything negative. S with negative s, y with negative y. So if I have y equal to absolute value x, negative y equal to negative x, we can see that here we get negative y equal to x. So it's not the same. So this means the graph is not symmetry about the origin. It's only symmetry about the y-axis, because when we replace x and negative x, absolute value gives us the same x. So we can see we have our symmetry across y-axis. So we plot some points. The test grab the equation by plotting some points. We have from 0 to 4, and y gives us the same thing, 0 to 4, so we get linear. Now, since we get this value, and we test all the three, the x-axis, the y-axis, the point of origin, the origin axis, and we find out that the y-axis, when x is negative and is positive, the answer is the same. So that means there's a symmetry across the y-axis. So that's why we got the shape here. Now, if it's a symmetry across the x-axis, then this line will be down. It will be on the positive x and negative y plane. So next is how to identify the center and the radius of a circle. So first, we know a circle is a set of points in a plane that are fixed distance from the point called its center, and the fixed distance is the radius of the circle. So first, let's go back to a circle, then okay, I don't have the image, but it's almost at the end, so we'll come back to it. So again, that's the definition of a circle. When you draw a circle, you see that when you are at the center of the circle, from the center of the circle to any of the circle line, the radius are the same. And that's the definition here. We say a circle is a set of all points in a plane on the circle line plane. A fixed distance from the point called its center. Now, the fixed distance is the radius of a circle. So if I draw a circle line, I'm in the center. From the center to the circle, any point on the circle plane is the radius and is constant. So the graph of any equation that can be written in the standard form, and that's for the circle, will be s minus h squared plus y minus k squared equal to r squared. This will be the standard form of an equation of a circle with the center at h and k. H will be our center on the horizontal, and k will be the vertical. Sometimes h and k can be the center of origin, 0, 0, but it can be any value, negative 2 and 4. The circle don't have to be in the center. So again, that is the standard form of equation of a circle, s minus h squared plus y minus k squared equal to r squared. And r is the radius of the circle. The center of the circle is hk. So sometimes we may have a question. The question will give it the center of the circle and the radius, and they say we should write the equation of the circle. So we use this formula, then we substitute the h, k, and r value, and we get the equation of the circle. Now, if we are in the center of the origin of the circle, remember it to be 0, 0, then the equation will be s squared plus y squared equal to r squared, because it will be s minus h all squared, but h is 0, so s minus h, s minus 0 is x. Same thing, k will be 0, so y minus k is y. So if the circle center is the origin, the point of origin where the center is 0, y-axis s at 0, then this will be the formula, s squared plus y squared equal to r squared. So now we have a question here. They say we should find the center and the radius of a circle with the following equation. So the center will be, remember the equation standard form is s minus h squared plus y minus k squared. So h, the center will be minus 3 is given here. Remember the formula is s minus h. So that means this 3 will be positive. So my h will be positive 3. But I need minus value here. So it will be y minus minus 2. So that means k will be minus 2. So that we get minus here. Then remember this will be square. So r square is 36. That means r will be 6. So let's see the solution. Here we say that since the equation is written in the standard form, we can, again, here we say that since the equation is written in standard form, we can identify h, k, and r very quickly. Remember this, the equation again, s minus h squared plus y minus k squared equal to r squared. We already have minus 3, so 3 should be positive. We have plus 2, so plus 2 should be negative, so it will be minus minus 2. Then 36 means 6 squared, so r. So here we have h equal to 3, k is minus 2, and r is 6. So the center of the circle will be 3 and negative 2. The radius will be 6, based on the equation given here. Now, the next session, we're going to learn how to write the equation of a circle. So the question given here, they say we should write an equation of a circle with a center negative 2 and 4, and the radius is given to us. So the same thing we have to do, negative 2 will be h, 4 will be k, radius is 1. So we know the standard form of equation of a circle is s minus h squared plus y minus k squared equal to r squared. So it will be s minus minus 2, h is minus 2, plus y minus, because it's 4 positive, so it will be minus 4 squared equal to 1 squared. So minus minus will give me plus, so I'll get s plus 2 squared plus y minus 4 squared. 1 squared is 1, so I'll get 1. So the equation of the circle with the center negative 2 and 4, and also radius 1 is to be s plus 2 all square plus y minus 4 all square equal to 1. Again, this is our standard form of circle equation. That's what we have to use because the center is given to us, h and k, and the radius is given. So we substitute the values for h and k and r and simplify it. So next is how to graph circles. So they say we should graph the circle whose equation is this. First of all, we can see here we have 2s squared plus 2y squared minus 8s plus 4y minus 40 equal to 0. When we want to graph a circle, first thing we need is the center of the circle. Remember, this is not the same as graphing a straight line or linear or graphing non-linear lines like parabola, etc. We are graphing a circle now. So a circle, we need a center. If I know the center and I know the radius, then I can be able to graph the circle. So here we say we need to convert the general equation of the circle into the standard form. Remember, when we change the equation to a standard form, we can automatically see the h, k, and r. Here I can't say r is 0 because this equation is not in standard form. So we don't even know the h and k. So that's the first thing we need to do. So again, this is the equation. We have 2x squared plus 2y squared minus 8x plus 4y minus 40. We saw that 2 is common among everything, all the values here. So we divide everything by 2. We get x squared plus y squared minus 4x plus 2y minus 20 equal to 0. Now, to find the coordinate of the center and the radius, we're going to add 20 to both sides and write the equation in standard form by completing the square of both x and y. So this minus 20, we take it to the right side. So we have x squared plus y squared minus 4x plus 2y. Then here we are going to complete the square so that we have a perfect square for x-axis and for y-axis. So here we can see that we combine the x-axis together. We have x squared plus y squared minus 4x plus 2y. So we bring x squared minus 4x, then y squared plus 2y equal. Now we need to complete the squares. We know that in order for me to get s minus 2 all square or s minus any value all square, I need to have, let's say we know perfect square. A minus b all square is the same as a square minus 2ab plus b square. So that's what we want to complete here. So I have x squared minus 4x. So to complete this square, here I'm supposed to get 2x and y. So what's the value of y? The y should be 2 because I'll get 2 times 2x. So that's why, and then y should be y squared. So instead of writing 2, I write 4, 2 squared. The same thing, I'll come here, I have y squared plus 2y. So here's supposed to be 2sy. We have y. So the other value should be only 1 because we have 2 already. 2, 1, y will give me 2y. So that's why we had 1 here. 1 square is same 1, so we had 1. So this means to complete the square for x and y, we had 4 and 1, which is 5. We are going to do the same thing to the right side of the equation to balance it. So now we are ready to go. This is perfect square. S squared minus 4s plus 4 is the same as saying s minus 2 all square, because s minus 2 all square is s squared minus 2 times 2x plus 2 square, which is what we have here. So I'll get s minus 2 all square plus, this gave me a perfect square of y. This is plus here, so it will be y plus 1 all square. Y plus, so y plus 1 all square will give me y squared plus 2y plus 1 equal to 25. But we need to change this to negative. Remember, the standard form is s minus h all square plus y minus k all square. So we get s minus 2 all square plus y minus 1 all square, and then 25 is 5 square. So we almost done now. We can graph our equation. The center of the circle will be positive 2 and negative 1. Again, h is x-axis and y section, negative 1 will be the y-axis. The radius, we know the measurement to be 5. So here we say from the standard form of the equation of the circle, we see that its radius is 5 and the center of the circle is at 2 and negative 1. So we get our graph book. 2 and negative 1 is here, negative 1 for y, 2. And I will measure anywhere from that point. It can be any direction. We get 5. So, okay, then I'll draw my arc. I'll stand at the center and draw the line. So anywhere from the center should be, radius should be 5 throughout. So we can see again, graphing a circle is different from graphing a linear line or a non-linear polynomial. When you're graphing a circle, only 2 things you need: the center of the circle and the radius. If I get the radius and I know where I will start from, which is the center of the circle, then I'll just draw a circle from the center. So this will be the conclusion of our lectures. Again, these lectures, we did a little bit review of graphing and also the symmetry, which we talk about the concept in our previous lectures, also the y and x intercept of a graph. The new thing we learn here again is circle. First, how to identify the center and radius of a circle. You need to find the standard form of the circle equation. Then you look for the h, k, and r. H and k will be the center. H represent the x-axis, k represent the y-axis. The r is the radius. So when you know these three items, we can graph the circle. Stand at the center, measure the radius, and draw a circle around the center. So again, wish everybody the best, and thank you.